Pow-Wow, a dataset and study. Pow-Wow, a dataset and study on collaborative communication in Pommerman. Communication is a crucial part of human collaboration, and it enables people to effectively collaborate with each other. A natural desire that comes up is to equip communication with artificial agents to enable efficient collaboration. But how can we do that? A straightforward way is to learn it from scratch by interacting with other agents and the environment. This is known as emergent communication. However, due to its complexity, current emergent communication focuses only on a very simple environment and communication. In this work, we do not try to learn communication from scratch, but rather we collect and analyze the communication between humans in a collaborative task, and then design effective communication for agents based on the analysis. To demonstrate this, we employed a 2 versus 2 competitive game environment called Pommerman. In this game, agents walk around in a grid world and aim to kill the enemies with bombs. In Pommerman, agents' observations are limited to their surroundings, and thus effective communication can potentially provide an advantage. We asked a pair of human players to play the game against top models from a Pommerman competition. Human players are allowed to communicate via text-based chat during the game. The top models use tree search to plan and choose an action, and they do not communicate with each other. We recorded game states and dialogues between the players and released the collected data for further research. Having game logs and dialogues collected, our next step is to analyze what types of communication are used by human players and what contributes to a successful result in the game. To perform analysis, we defined 25 categories of communication and annotated the dialogue in each time step in the game. We then visualized the frequencies of communication types with respect to the time step. The analysis showed that players commonly share its own location and enemy's location. And in successful games, people frequently use action-centric communication, such as sharing the intention and suggesting actions to the teammate. We picked 2 types of communication that are commonly exchanged, own location and target enemy's location, and implemented them in the learning agents. These communications are implemented in a very simple way by extending agent's observation. To communicate its own location, we simply include the agent's location on the teammate's observation. If an enemy is spotted, its location is also reflected in the observation. These simple ways of realizing the communication may have limitations. However, it has an advantage that the shared information can be immediately understood, since it's just an extension of a normal observation. With reinforcement learning, we train the agents that communicate and another pair of agents that do not communicate against baseline agents provided in Pommerman. After conducting 50 matches against the baseline agents, the learning agents with communication presented a better win rate. As a conclusion, we saw that there are clear patterns of communication that are useful in human play, and by incorporating some of the communication into learning agents, the agents can utilize it to improve their performance. We note that we chose the simplest and most prominent examples of communication to use in our model, but we identify many more. Learning these forms of collaboration will be more difficult, and we leave this for future work. We believe that the presented scheme that analyzes human communication and learns communicative agents based on it motivates a larger scale research in the multi-agent and NLP field.